Chloe, okay? Yes. And so we can like look at you and I can be like, Ethan. Yeah, I know. Here, just cross that out and write it real big underneath. Is it Elias or Elias? Elias. Elias. Okay. Because it's not Elias. Because I make sure and you Alright, let's see those name tags. Yes. Take that one. Just your first name. Sitlali? Sitlali?
Wait, would you have Pearl?
And then Eric. Paul. Matt's after your name. Ready to read that? So stick it on your...
Natalie not here?
What's your name? You got your name tag?
Where's Ivan?
He's somewhere.
Was it? Oh, both checked out.
He checked in late. And you have this song.
Maybe you should go.
There you go, buddy.
I haven't seen it. I'm trying to rip it off. You're ripping your full knee.
Sterling, are you a lawyer? Cool, hear that. Sterling, cool, hear that.
No, you want to talk about
Alright, hey guys.
Were you Ivan?
For those of you who don't know me, I'm Miss Cash. And before we get started, I want to make sure that everybody has a name tag, that you've written your name on it where we can read it, and that you're wearing it. Okay? If you don't have a name tag because you came in a little late, maybe raise your hand. One of these lovely ladies will bring you a name tag. Alright, I know there's a lot of new faces in here, and I'm going to explain why. Raise your hand if you've ever worked to get better at something. Maybe a sport, maybe a subject, driving, anything. You've worked to get better at something. That's what all of us grown-ups are doing. We are working to get better at something, so we're trying something new today. So as we go through the activities, I want you to focus on your learning just like every other day. We're going to be trading off. But at the end of the lesson, we're going to come back and you're going to give us some feedback. Nothing crazy, just did you enjoy it, did you not? Okay, because we're learning to get better. Okay? Alright, to kick off our lesson, we're going to watch a quick little video. While you are watching this video, I want you to get out a piece of paper and you're going to write down any science, physics words that you hear. Okay? You need paper, something to write with, and when the video comes up, you're listening for physics words and you're going to write them down. Any questions over what we are doing at the beginning?
Introducing the new.
Don't worry, that's just the advertisement.
Capital One Saver Card. Earn 4% cash back on dining and 4% on entertainment. Now when you go out, you cash in. What's in your wallet?
Alright, here's the video. So we're focused on that, not our phones.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, as I'm committing crimes with both direction and magnitude. Oh yeah!
Alright, what are some Magnitude. Vector.
Mathematical arrow.
Mathematical error. Directions. What do you think we're going to be talking about today?
Vector.
All of those words that you just named out, right?
Scalars.
You've heard them before? Maybe? You remember anything about them? No? Well, luckily for you, we're going to be talking about it today, Zane.
Alright guys, I'm Ms. Hess, and I'm a living example of what it looks like to do something you're not comfortable with. Okay, I teach marketing. Physics is nowhere on my scale, but I've learned more about physics in about an hour, and I'm hoping you guys will leave the same info that I have just learned. So, we're going to do a quick exercise. So, you're going to be shown 2 images. We're going to pass these out, so if you'll take one, pass it around here, Cody. Thank you. So, it looks like this. So, the first column says image 1. I want you to write down M&Ms, like the candy. So, go ahead and write that down on the top of the column, M&Ms. And you've got 4 terms in the middle, but the last one's repeated twice, so there's really just 3. So I want you to look at this image of the M&Ms, the candy, write down numbers, size, and motion. So in the left-hand column, under image 1, which you'll put in M&Ms, I want you to write down anything that you notice about these that have something to do with numbers, size, and motion. I'm going to give you about 1 minute. And again, using physics terms. Look at the size, number, and motion. I know, just ignore the last one. You just cross that out. Okay, I'm going to give you about 10 more seconds. Okay, raise your hand if you still need about another minute. Okay. Remember to use physics terms when you're answering these. Right down to 20. Okay. We're going to all right, 30 more seconds. Just whatever comes to mind, we're going to discuss. Okay, let's see. Ivan, I'm sorry. What'd you put down, buddy, for numbers?
There's 26.
26? How many of y'all said 26?
I said 20.
You said 24? How many of you said 24?
25.
Okay. Who's right?
There's 25.
Are you sure? Why?
There's 25. There's 25.
Maybe there's more.
Maybe there's more?
Yeah.
Okay. What about size? Asher, what'd you put for size?
They're all the same size.
All the same size? Why? Because they're M&Ms? What are M&Ms, what do you think that they are produced in to get them all the same size? Molds, okay? And motion, what's happening?
They're not moving.
Not moving. What, say that again, Ethan? No, at rest. That's a physics term, right? I learned that's a physics term, so great job. Okay, let's move on to the second image. Again, using physics terms, look at this next one. So again, on this one, numbers, size, and motion. Look at everything that's moving. Okay, so on the last one where it says motion, I want you to change that, and I want you to put measurable. So what is measurable in this image? So cross out motion, measurable.
The second one?
Yes, number 4 where it says motion twice. Cross that one out and put measurable. If you did the first one, that's fine, as long as you cover motion too.
MBASU. Of course, keep every day, every now and then.
So, all right, let's think about him. He knows he's about to probably get butchered for Thanksgiving. How fast do you think he's going to run?
I did.
I put medium rare.
All right, I hear giggles back here. Is that a good thing? Or is it
I asked what size is the medium.
a medium-sized turkey? Medium rare? How do you eat turkey? How do you eat turkey?
You got it.
First, drain it out. All right, come on, help me out. Stop waiting. How?
Do you care?
How do you know? Maybe you can.
No, because look. All the things look the same.
Are you sure that they're the same?
You don't know when to stop.
He's just constantly running.
I'm going to call on you to talk about that. What's your name, Steve? I love that. Pour those some milk on those and eat like cereal. At y'all's age, y'all should do that. At our age, you can't.
Hey, what are you saying about
It won't come off. I don't know how old you are, but I'm pushing 40. That didn't come off. What's on the lips, forever on the hips. Remember that. My hips look different now. Okay. Who still needs some time? This one was a little more to look at. Okay. Ivan, share with us what you shared with me just a minute ago about this turkey.
Oh. He's going at a constant speed.
Say that again.
He's going at a constant speed.
He's going at a constant speed. Now, how would we know that?
Well, because it doesn't.
He's going fast.
He's not speeding up.
It's not accelerating.
How do we know he's not accelerating?
It's always accelerating.
So they said that the leaves are kind of falling the same speed every time, right? How would we know if they were going faster or slower? Okay. All right. So what is measurable in this?
The distance.
Okay. All right, Chandler, what'd you put down for size?
For size?
Uh-huh. Oh, I'm sorry.
Yay big.
Yay big. Is that a physics term? Just yay big?
It's not.
Ivan, what'd you put down?
I just put it
You said medium.
Oh yeah,
He was talking about how to eat it, like medium rare. Not, I don't know that I've ever thought about that with a turkey before.
No.
Okay, great job. Okay, Mr. Ryan, or Mr. Is going to dig a little deeper with this.
Alright, so you've described the two images. How would you say that the two images are the same? Talk that over in your group really quick. What do you think is similar about the M&Ms and what do you think is similar about the turkey?
There's no way. Like a turkey that's
Okay, let's get one person from each group to share a similarity. Zane, do you have a similarity, something in your group? Okay, just a second. I'd like to hear what Zane's saying. I'd like to hear what Zane's saying. Zane, something that your group shared that was similar. You can measure the size, the distance, okay? What did y'all say? Alright, I'll move on. Someone over here. Nose goes.
They said they're both foods.
They're both foods? Alright, I'll give you that. What about over here?
I think the young babies
Okay, they said they both had color. Now we're hoping that we can draw some physics similarities. Those are good, but do we have a physics similarity? The acceleration of both of them equals 0. Good. Okay. Both have a constant velocity. That's right. What's the constant velocity of the M&Ms? 0. Okay. So we see there's some similarities between them. Now in your group, discuss the differences between the two. Discuss the differences between the two.
Oh my gosh, it's
There's no.
He wants to.
Write them down.
Ricardo came up with a really good one. One's a snack and one's a meal, but remember we're trying to look for differences that have to do with physics. Okay, so if you would try to keep your topic on physics differences.
We're hungry.
Which one's the meal for you?
Okay, let's go around and share again. Maybe a different person from each group. So we'll start over here. Somebody over here. What was the difference that you saw? Okay, one's at rest and one's moving in a different direction. Okay, what do you got? Okay. Can we come back to y'all?
No, she has another one.
Oh, you have another one? Differences between the two.
There's more M&Ms than there is.
How do you know?
Because there's only one turkey.
Because you did what? You counted them. Okay. What was the difference? What? One was moving. What about the other one? It's not moving.
One's at rest, one's at speed.
One's at rest and one's at a constant speed. Okay. Something else? One is bigger. How do you know? How could you prove it? How would you show somebody that? How would you record that on paper? How would you measure it?
Write it down.
The weight. Okay, so we could get the mass and scale it. Okay, what do I hear?
It's a larger variety of M&Ms than there are.
Larger variety of M&Ms than there are turkeys. Okay. All right. So let's do one more comparison. We're going to get everybody to stand up in just a second, but let me explain first. We have the turkey, and then we have the video that we watched in the very beginning. The villain. What was the villain's name?
Vector.
Yeah, I don't know that one. We were more interested in the one that was talking. Vector, right? So the villain's name was Vector. And I want to know, do you feel like the turkey and the villain are more similar or more different? So think about that for a second, then I'm going to get you to stand up and show what you think. Are they more similar or are they more different? More better or more... I mean, just kidding. More similar or more different? Oh, and why? And why? What's your reason?
Oh, dude, the video was moving a lot. The guy was just standing there. Yeah, exactly. And the other guy was just standing there.
Okay, so here's what we're going to do. If you think that Vector and Gobbler are more similar, please come stand against this wall. If you think that they are more similar, please come stand on this side of the room. If you think they are more different, please stand on that side of the room. Remember, you're going to have to tell me why you think they're more similar. Come on, you know they're different. More similar or more different?
Don't be afraid to stand alone, but if that's what you feel.
Okay, stand over there as long as you have a reason why. Absolutely.
Can I stand in the middle?
No. One side or the other. So in fact, why don't you tell us why you think they're more similar? Come on, you're over here. Tell us why you decided on more similar, even though you think you want to put yourself in the middle. What made you choose this one when you had to choose?
Because they're both moving.
Because they're both moving. Okay. Anybody else over here? Cody, I heard you saying some good things earlier. Do you think you want to share any reason why?
Of course he doesn't want to. But come on, Cody. Man up.
They both have magnitude. I'm sorry, what is magnitude? Do you remember? Okay. So they both have magnitude and direction. Okay, now you wanted to share? Same thing. And Henry, did you say? They both have magnitude and direction. Okay? Now, why do you think that they are more different?
Because they don't have direction. It's not specifically saying where it's going, north, south, just say no direction.
Okay? So you don't feel like that they have direction. You feel like the turkey is just moving at a speed, but has no direction in life. Okay, he'll have direction come Thanksgiving.
That's right.
Okay? All right, hey, I think that's fair. Let's all have a seat. Okay?
Sorry, you guys do great.
Okay, so the two words that we're trying to get you to learn today is the word vector, which I've already heard some of you say. What is the two parts of a vector? Direction and magnitude, okay? And so what would be an example of a vector?
30 miles south, 30 miles south.
30 miles per hour south. So we have a magnitude. What's another way of saying magnitude? Say it again. Say what you just said. A numeric value. Okay, so 30 is a number, right? And then south is a direction. Does anybody else have another one? Okay, we'll keep going. What is a, if you're not a vector, then what would it be? Scalar. So I didn't know if y'all remember that word or not. So a scalar is not the opposite of, but it's part of a vector, right? And scalar has what? Speed is an example. Mass. What do you mean mass? Does mass not have a direction? No. No? Okay, I agree with you. That's good. Okay. All right, so you understand now that there's this thing called a vector, there's this thing called a scalar. We've seen the villain vector, you understand that. We're going to pass out an article. And the article is not so much an article. Y'all know Miss Gibson in the Media Center, right?
Yes.
Her husband was a sergeant in the U.S. Marine Corps, and he took part in the Battle of Fallujah in Iraq, and he wrote this for us.
Oh, wow.
And it's kind of a job description about what a sergeant in the U.S. Marine Corps would do for the artillery. And so it's talking about the cannons that he fired on Fallujah.
That's good.
Okay, I'm going to have you guys go ahead and read this article. And as you read the article, you're going to look for those physics terms that you've learned about. And if you find one of those physics terms, you're going to have to decide whether it's scalar or vector. If it's scalar, you're going to circle it. And if it's a vector, you're going to put your arrow underneath it. So it's like underlining it with your arrow. Okay, so go ahead and read through that by yourself and find all those physics terms that you're looking for. Yes, right on.
Just read.
Remember, vectors, you're going to put a vector underneath it. Scalars, you're going to circle. Okay, so what are some of the words that you guys found, since we're all starting to finish up here? What's some words that you found? What'd you find? Air temperature. What is that, scalar or vector? Scalar, very good, because it just shows us our magnitude, but there's no direction, right? Eric, what'd you find?
Vector word in the first one, first line.
Yeah, the second paragraph, right here.
Yeah.
What'd you find?
Mass.
I'm sorry?
Mass.
Mass?
Yeah.
And what would you get for that?
Vector.
Mass is not a vector. Mass would be scalar. Because what does mass have? Has a number, right? What's the other thing besides mass? Weight. And weight is a vector, because that will take in consideration the fact that you have gravity pushing down on it. But mass is just a number. So that would be scalar. What else do we have? What'd you get over here? What'd you get? 3,000 meters. So what would that be? Okay, do I have mass? And I have direction. Because where does it say? Meters where? Meters above, right? So if it says 1,000 meters above, what do I have? I have both magnitude and direction. So what would that be? Magnitude and direction is a vector. Okay? What else? Asher, what'd you get?
Air density.
Air density. What do you think that is?
Vector.
Okay, do you have direction and air density? Okay, what is density? Mass divided by volume, right? So do I have a direction in there?
Yeah.
What direction is it? I have magnitude, but do I have a direction? If I don't have direction, it has to be scalar. So that one would be scalar. Okay, Ivan, what'd you get?
Well, barometric pressure.
Barometric pressure. What do you think that is?
Scalar.
That is scalar. Very good. What'd you get? Huh? You have some stuff underlined there?
You got it.
I see that one. That you have one that's 2,000. What do you have right here? What did I just see? All right, 7,000 meters what? Or more. So what would that be?
You know this.
Because it says from ground level to 7,000 meters or more. So what'd that give me? That gave me magnitude, and what else did it give me? From ground level up, right? So it's also direction. So if it's magnitude and direction, what is it? What did you do? Did you underline it or circle it? You have it right. Did you underline it or circle it? That's right, because it's a vector. So it should be underlined because it's a vector. Right? What did you get right here, Destiny? Right? She has distance. Would distance be scalar or a vector? Which one? Okay, remember it has magnitude and direction. Is your distance going to give you a direction? Yes, so therefore it should be a vector. Okay, anybody saying math words in there?
I see math. Calculations.
See math calculations? How about quadrant? Because I'm a math teacher.
Oh yeah, I see quadrants.
So quadrant, you have how many quadrants? 4. And based on where we go on the quadrants, what do I know? Magnitude tells me how many I go in each direction. And then what? The direction in which I go it, right? So that would be scalar or vector? Vector, really? Very good. All right. I see another math word somewhere. How about coordinates?
Yes.
Coordinates would be what then? Vector, because that goes with my quadrant.
Calculated.
Okay.
Calculations?
What do you have?
Calculations?
Calculations would not be either, would it?
Maybe.
Maybe. If it's a number. If you give a number, it would be scalar. Unless it also has your direction like positive or negative. Okay?
What about the year?
units of time.
Time, and time is what? Magnitude only, not direction, right?
So it's a scalar.
So it's scalar, right? Yes. 2004, that would be scalar, right? Okay. What about deflection? What would deflection be? Scalar or vector? Vector why? Because what does it say in parentheses right beside it? Left or right. Okay? And then, missing a whole bunch here. How about velocity? What would velocity be? A vector, why? From math, what do you always have to include when you have velocity? Direction, right? Positive would be which way? Or up. And negative would be left or down, right? So as long as I'm being told a direction, it's then a vector. Okay.
Alright guys, my name is Miss Crawford. Hi. We're going to see what all you guys learned today, okay? So, y'all done this little activity before, it's called a memory box. And so, it's going to be fun, and we're going to make a little competition out of it. So, on the back of your notes that you took about the turkey and M&Ms, the differences and comparison, okay, I want you to write down, I'm going to give you about a minute and a half, I want you to write down as many physics words, measurement, science words that you can remember that we talked about today. So think about the comparison, think about the article you just read, as many physics, science, measurement type words that you can think of. A minute and a half.
And I think the winner gets candy, right?
Yes.
Tomorrow you'll get
Kidding.
Miss Crawford said she has candy in her room, but she's not confident.
About 15 more seconds. Guys, let's go ahead and put pencils down. And what I'm going to give you a second to do, we're going to make this a little competition between groups. Give you about a minute, and I want you to go around in your group and share your list. That way, if you've got somebody in your group thought of something that you didn't think of, y'all can combine your list, okay? You can add on. So just about a minute, I want you to each go around and quickly share your list and see, compare what you've got. Okay, see if you've got something that you can add and come up with as a group. Give everybody a chance to go.
Magnitude, direction, time, speed, scalar, vector, Not yet. Sorry. Calculation. I put water. I got adjustment. That's what we talk about. Yep. No, altitude.
Constant speed.
Yep. Yep.
Scalar has
We have 2004. What wind speed? Pressure. No, it's not. Speed is speed. Except for
Few more seconds, then we're gonna look at what we've got.
you want me to fix it? Want me to
Alright guys. Alright, let's look at what we've got, okay? We'll start with this group right here. How many did you guys come up with? Yes, you gotta know who's the winner.
Here, count them up.
Count them up.
Yeah. You should all have the same number on your sheet.
I got
16. Okay, I've got.
Do we add all of them together?
You should all have the same.
Your combined list, like your combined list.
31.
No way.
No, 31 together.
I have 21. So, 2.
I don't know. We're about to sign out.
Wait, what? The same ones on your sheet. Don't I do that?
Yes, we did. Alright, so make sure they're combined and then count them all up.
So, we have many
Alright guys, let's look at our list. We've got 21 right here. 21. Did anybody beat 21? No, just your combined list. Like meaning just your.
Mine's 20, his is 16, his is 18.
Like if you have the same words, that's just one. We got 21, 21, 28. Okay. Alright, we got 28. Did anybody beat 28? Alright, I think 28 is our winner. Real quick, go down your list for us, our 28. Are we reading for us real quick? And just listen, because if you have something that if they have something you don't, go ahead and include that in your list, okay?
Vector, left to right, up and down, positive, negative, constant speed, rest, unit, size, day on mass, air temperature, pressure, wind, meter, direction, arrows, minutes, velocity, magnitude, and constant velocity.
Okay, awesome, good job. Alright, so that's awesome, that group is our winner. Good job. But remember, our goal for today is to be able to classify things as what? Vectors or scalars, okay? So I want you to look at your list, okay? And I want you to classify what you've got as either a scalar or a vector. And you can classify them the same way we did in the article. You can draw your vector arrow underneath the ones that are vectors, and then circle the ones that are scalars, okay? Okay. Classify everything you've got as either a scalar or a vector.
your list? Come on. Let's do this last part. Show me. You know this. Well, you're gonna prove me wrong. What is vector?
I saw one group where they had a big T chart and they were actually writing the words on the vector side or the scalar side. If it helps you to visually organize it.
Scalar or scalar? Maybe I should do that. Directions you can try.
Direction. Well, if I tell you, you need to go
I like that.
in this direction, this way, north, you want to know how much, right? So what would that be?
Vector. This two.
How's it going, lady? Oh yeah.
Speed is. Speed Distance is Made eye contact with the camera 4
I still need to see how
I can tell you that one. Everybody's seen
Are we turning the image? Look at the top.
Yes.
Are we going to watch it right now or no?
We have 1 minute. What are they doing? Alright. Hopefully we can wrap up deciding if our list, what words on our list are scalars and which ones are vectors. I need you, in just a second, you're going to put this in your notebook, but before you do that, I told you I was going to ask you for some feedback, right?
Yeah.
You can be completely honest. It's not going to hurt our feelings. Like I said at the beginning, we're here because we're trying to get better at something. So all I need is a simple thumbs up if you enjoyed the activities today, a thumbs down if you didn't.
Let's see some thumbs.
Hey, we're not going to leave until I see thumbs.
I'm going with the end.
What? That is not